Hello everyone, I'm Aarizul Hoda from class 10th. I study in Kendra Vidyalaya ISC in Bangalore. I have made this project called e-VAMP. It is a navigation aid for people with visual impairment and for elderly people with deteriorating vision and for people in low light conditions. It is a vest that you wear over your normal clothing. It has an array of ultrasonic sensors that will help you detect obstacles in front of you. Blind people face a lot of issues in their day-to-day lives. They have to carry a walking stick all around. They have to have one person constantly with them, and that causes a lot of issues for them. So this can help them mitigate those issues and navigate their surroundings with ease. So basically, when the blind person will walk close to an obstacle, there's a vibration motor that will start to buzz, and it will alert them there's an obstacle in front of them. Depending on the distance of the obstacle, it will give them a different buzz, so they can know how far the obstacle is from them. So basically, in the obstacle, like the detection starts from 100 centimeters away. So when 100 centimeters away, it will give a long buzz with a long pause, and the shorter distance you go, shorter, the buzzes will like the length of the buzzes and the length of the delay will decrease. So there's different buzzings for 100 centimeters, 75 centimeters, 50 centimeters, and 25 centimeters. And at 25 centimeters, there'll just be constant buzzing, so they can know just something right in front of them. This entire thing is based on the principle of ultrasound. Ultrasound is a very high frequency of sound, over 20 kilohertz. It cannot be heard by humans. It's used by bats and dolphins for echolocation. It's also used in ships to measure the depth of the sea. That's called sonar. I've been using this principle for the obstacle detection. So this is an ultrasound module which has a transmitter and a receiver. So the transmitter will transmit the ultrasound wave, which will go and hit the wall and bounce back, and it will be caught by the receiver. We can calculate the time difference between these two, between the sending of the sound wave and the receiving of the sound wave, and we can calculate the distance between them by just multiplying it with the speed of sound, which is a constant in air. So this is the vest. These are the ultrasonic sensors. This is the transmitter and this is the receiver. There are 3 ultrasonic sensors which are all connected to the Arduino board, which is a microcontroller, and which is powered by the battery, which is held in a battery case. So as you can see over here, these 3 are the sensors, and this is the Arduino board. One sensor has 2 pins. One is called the trigger pin and one is called the echo pin. So in the trigger pin, we have the Arduino board constantly sending a pulse to the trigger pin, which basically tells it to keep transmitting ultrasound waves. So, and all of the results of when the ultrasound wave comes back is carried through the echo pin and goes back to the Arduino board. And the Arduino board calculates the distance between the two. So whenever the distance goes below 100 centimeters, the Arduino board will, there's a if statement that will just go and will tell the vibration motor to start buzzing. And so I'm just going to show a demonstration of that. You can just wear this vest normally, like that, and it's ready to go. It can go over any normal clothing. And I switch it on now. So as you can see, there's no obstacle in front of me, so there's no buzzing. I'm going to use this anklet to amplify the sound so that you can hear it, but it's actually being felt in my body, like I can feel the vibrations. This is so that if a blind person were to go in a loud environment, then they would still be able to feel the vibrations and they wouldn't have to try and listen to it. So I'm just going to put it over here. And now when that obstacle in front of me, when I just turn, it starts buzzing. That is a 100 centimeter buzz that it gives. When I go closer and closer, it switches to the 75 centimeter one. When I go even closer, it switches to the 50 centimeter one. And now I go even closer, now it's the 25 centimeter one. So this can help them know exactly how far the obstacle is. So this product is still at its prototype stage. in the future, I'm planning to add another downward facing sensor that can help them detect stairs and potholes that might be in the ground, and also making this entire system more compact, because this is quite bulky right now, and to make it overall a lot cleaner. Thank you.